Hello everyone, you are watching my YouTube channel Chemistry by Saad Anwar, and today we are going to discuss a quantitative chemistry complete chapter. I will just try to make one or two video on this topic. We'll discuss from the basic to the peak. This lesson is equally important for GCSE and WJEC. Guys, if you need my one-on-one tutoring sessions, feel free to contact me via this WhatsApp number. The topics to be discussed in this lesson is relative atomic mass, relative formula mass, the mole, the Avogadro constant, how many moles, calculation in moles, calculating reacting masses using moles to balance equations. The topics to be discussed continue: limiting reactant and excess reactant, percentage yield, atom economy, volume of gases. I will reacting volume of gases. I will try to make videos on these topics. Basically, what relative atomic mass is. Relative atomic mass is mass of an element. In simple words, we will say average mass of an element. And this is what you can get from periodic table. When you open periodic table, you will find the atomic masses of all of those elements. For example, in periodic table, oxygen, its atomic mass is 16. For sodium, its atomic mass is 23. For potassium, its atomic mass is 39. So this is relative atomic mass. I am just trying to make things easy. Everything is given in book. I am just trying to make things easy for you guys. Then relative formula mass or molar mass. We need to calculate molar mass. Molar mass is basically mass of 1 mole, mass of 1 mole of substance, mass of 1 mole of substance. This is the molar mass. For example, water in periodic table, you will find oxygen relative atomic mass AR for oxygen is 16. For hydrogen, its AR is 1. So there is 2 times hydrogen. So we multiply with 2, we put 16 here. So this is 18 gram per mole. So this is how we calculate relative atomic mass. Now, for example, I have to find the relative atomic mass of sulfuric acid. I just need to care in periodic table, you will find hydrogen, its AR is 1. In sulfur, its AR would be 32. For oxygen, its atomic mass is 16. So what you do, you put 1 here because there is 2 times hydrogen. Don't forget to multiply this with 2. Sulfur relative atomic mass is 16. Sulfur relative atomic mass is 32. Oxygen relative atomic mass is 16. Don't forget to multiply this with 4. So when you solve it, guys, you will be getting 98. So this is the MR of sulfuric acid. Let's try a bit harder things like magnesium nitrate. So if I have to find its relative atomic mass, I just open periodic table. Magnesium AR is 24. Nitrogen AR is 14. So here I put 24. While for nitrogen, this is 14, but this is 2 times nitrogen. So I multiply with 2. Oxygen is 6. 1 oxygen is 16, and this is 6 times oxygen. You see, 6 times oxygen. So when you solve this by using calculator, you will be getting an answer, and this would be 148 gram per mole. Now, guys, I would say do try to find the MR of this ammonium sulfate. Do try, okay? Then you can share in comment section, okay, guys? The mole and Avogadro constant. What is mole? Mole is just a number, a big number. 6.02 times 10 raised to power 23. This is 1 mole. So if I ask you what is mole, you can say mole is a big number. And we use mole to measure the amount of substances. Like generally speaking, you can say half glass of water, or if you are a guest, you can say, I am guest, I need 1 spoon sugar, I need 2 spoon sugar. But no, in chemistry, you will say amount of substance. You will say, I need 1 mole sugar, I need zero point 0.2 mole sugar, I need 5 mole water. So mole is measurement of amount of substances. And there is Avogadro constant. This Avogadro constant is 6.02 times 10 raised to power 23, and we use a symbol to represent this. In many calculation, you will find it very helpful. For example, this is a glass of water and it has a water molecules. I need to measure, I need to calculate number of water molecules. Then what I do, guys, I just multiply the moles with Avogadro numbers and A. So if you need to find number of particles, what basically particles means, particles can be atoms, particles can be molecules, particles can be ions. What you need to do, just multiply moles with Avogadro number. Avogadro number is a constant. Avogadro constant, its value is this. So guys, go over this, jumping to the next slide. Here we need to practice few calculation. There is a formula to find moles. Moles is equals to mass in gram upon mr. Remember, mass in gram, like many student, what they do, they mistakenly mention like this, mr over mass in gram. And this is wrong. This is completely wrong. So just be careful. For example, I need to find the moles in 2 kilogram of iron oxide. If I do moles is equals to 2 kilogram. Oh, this is wrong because in formula we need to put mass in gram. So first to convert this 2 kilogram into gram. So multiply this with 1,000, it will be 2,000. Then Fe2O3, you need to find its MR in periodic table. The AR, relative atomic mass of iron, is 56. So there is 2 times iron, so 56 times 2. For oxygen, its MR is 16, but there is 3 time oxygen, so multiply with 3. So guys, when you solve it, you will be getting 160. So when you need to calculate moles, put 160 here and divide this by, oh guys, I did the very same mistake. Put 2,000 gram here and divide this by 160 gram per mole, which is the unit. So the answer you will be getting is 12.5 moles. So this is how we find moles. If they would give us 50 milligram of sodium hydroxide and they ask us to find moles, what you need to do, guys, first to convert milligram into gram. To convert milligram into gram. So when you need to convert milligram into gram, remember, when you need to convert milligram into gram, divide by 1,000. Let's say 50 milligram, I need to convert this into gram, I will divide this by 1,000. This would be equal to 0.050 gram. So I have to find moles. So I put 0.050 gram here, and the MR of sodium hydroxide, it's 40, guys. So when you solve it, you will be getting the answer. You can write this -3 moles. So this is how we find moles if mass is given. Guys, sometimes what they do, they give us moles, like 20 moles of carbon dioxide, and they ask us to find mass. And they ask us to find mass. So what we need to do? Nothing. Use same approach. You guys know moles is equals to mass in gram over mr. You just need to rearrange this formula, guys. Just bring mr here. So it would be moles times mr is equals to mass in gram. So moles is 20 moles, mr of carbon dioxide. Yes, carbon is 12. Oxygen is 16 times 2. So this would be 44. So you put 44. And guys, when you solve it, this will be 880 grams. So this is mass in gram. Guys, for chlorine, remember in periodic table, its atomic mass 35.5 is given. But many elements they exist as diatomic form. So you would choose 35.5 times 2. For oxygen O2 it is 32. For nitrogen N2 it is 28. What is relative atomic mass? Now jump to the next. Calculating reacting masses. Guys, to solve this question, I would love to discuss with you a basic mathematics skills. I call it chocolate method. For example, I need to buy chocolate and chocolate, if I am not wrong in chocolate spelling, and the price. Okay, I am not sure about chocolate spelling. So this, if a chocolate price is 80 pound, just suppose if a chocolate price is 80 pound and you just need to buy one chocolate, then how many pound you have to pay? Yes, guys, how many pound you have to pay? What you do is just divide this number by this number. So guys, remember, whenever you need to do calculation for one chocolate, for one mole, for one atom, for 1 gram, for one, you need to divide whatever the number is here by this number, you will be getting the answer. But now let's say you're gonna buy two chocolate, one for you and one for me. So what you do, just multiply this, you will be getting the price. Just keep this basic mathematics in your mind. We're going to use the same approach in solving our problems here. Like the problem is, what mass of oxygen react with 4.6 gram of sodium? The balanced chemical equation is given here. To make it simple, what they have given you, first convert this into moles. Like they have given me mass of sodium. They have given me mass of sodium and this is 4.6 gram. Convert this into moles. So guys, moles of sodium. You guys now to convert moles, we need to divide mass by AR of sodium. You can see in periodic table, this is 23. So when you do this, you need a machine and it is calculator. Just kidding, 46 to 4.6 divide 23. Beware in calculation. Be careful in calculation because mistakes are very common. Just forget a digit and everything will be pell-mell. So this is 0.2 moles. Now, guys, I'm gonna use the very same approach. I call it chocolate method. Interesting, so yummy. What mass of oxygen? I have to find mass of oxygen. I need to do calculation for oxygen. Guys, put oxygen at the left of your paper. What they have given you, put at the right of your paper. Now do compare their molar ratio, sodium versus oxygen from balanced chemical equation. From balanced chemical equation, guys, you can see this is 4:1. Now just suppose you need to buy one, you need to have one sodium. So this is how many mole of oxygen is needed? Use this approach. Divide this number by this number. But guys, you have zero point 0.2 moles. Now use this approach, cross multiplication. So zero point 0.2 divided by 4. So your answer would be 0.05 moles. And guys, now you are expert in converting moles into mass. I'm expecting you can convert moles into mass. Is it? Do inform me, to comment, to share your feedback. So I have moles of oxygen. Why I need to convert moles into mass? Because they mentioned what mass of oxygen is 0.05. So mass, I just need to multiply moles with MR. So mole of oxygen is 0.05. So I must use the mole MR of oxygen, which is 32. In periodic table, you will find 16. But remember, oxygen exists as diatomic form, so 32. So this would be 1.6 gram, and this is your answer. Interesting. Go over this. I need to erase everything. Jumping to the next question. You can see the question looks from a past paper question interesting. A student wanted to make 11 gram of copper chloride. The equation is given here. Copper carbonate react with hydrochloric acid. Copper chloride is produced. The relative atomic masses is given. You do not need to peep into periodic table. Calculate the mass of copper carbonate. The student should react with dilute hydrochloric acid to make 11 gram of copper chloride. Interesting. In previous question, they have given us the amount of reactant and they ask us to calculate the amount of other reactant. Now they have given us the amount of product. Copper chloride is product. And they ask us calculate the amount of the reactant which is needed to make that particular amount of product. Use same approach. What they have given you, convert this into moles. So guys, mass of copper chloride is 11 gram. I need to convert this into moles. I know moles is equals to mass in gram over mr. So I need mr of copper chloride. CuCl2. Usually student write, so sometimes this is wrong. Focus here. Sometimes it works, but here sometimes it is wrong. So copper 63.5, chlorine 35.5. Don't forget to multiply with 2. So 63.5 plus 25.5 times 2. Guys, this would be 134.5 gram per mole. So 11 upon 134.5. So when you divide 11 by 134.5, you will be getting a moles of copper chloride. Now you need to find mass of copper carbonate. So just compare copper chloride with copper carbonate. Interesting. Whatever they have given you, put at the left of paper, but you need to find, put at the right of the paper. This trick will help you out to make things easy. I'm gonna mention copper carbonate at the right side of the paper to make my calculation easy. According to balanced chemical equation, this is 1 show 1. But I have copper chloride 0.081784. So obviously this should be 0.081784 copper carbonate. So this is the moles of copper carbonate. Can I convert this into mass? Yes. So mass of copper carbonate is moles times mr. Where is mr of copper carbonate? I need to find myself, guys. 63.5, carbon 12, 16 times 3. So guys, do use your calculator. Be careful during calculation. The answer is yes. What I am getting is 123.5. So 0.0817. In calculation, everyone can do mistake. I can do mistakes. If you find I have done mistakes somewhere, you can inform me in comment section of the video. So 10 gram. This is the mass of copper carbonate. Now calculating reacting masses. What mass of sodium oxide will form? Guys, what mass of sodium oxide will form if 9.20 gram of sodium is burned? So here, mass of sodium given to us, 0.920. And they ask us to calculate the mass of product. Mass of product. They ask us to calculate the mass of product. We use the same approach. What they have given us, convert this into moles. So moles of sodium would be equals to the mass, given mass divided by 23. Guys, what is 23? Relative atomic mass of sodium. So when you divide 0.920 by 23, that would be 0.04 mole. You need to compare sodium with oxygen. No, no, no. One of my students was comparing sodium with oxygen. That is a mistake. You are going to calculate mass of sodium oxide. They have given you sodium. So do compare sodium with what you have to calculate. What you have to calculate, to mention this at the right of the paper. Come to balanced chemical equation. This is 4:2. Just suppose you have 1 mole of sodium, divide whatever the number is here by whatever the number is this. But guys, you have 0.04 mole sodium. So do a cross multiplication. If you are expert in music mathematics, that is a good thing. But I just want to elucidate, I just want to explain everything just to make life easy. So mole of sodium oxide is 0.02. This is my answer? No. Why no? Because I need to find mass. So mass of sodium oxide. What we do, we multiply moles with MR. I have the moles of sodium oxide, but I don't have MR. I can find MR. Is it tricky? No. Sodium 23, how many sodium? 2, so do multiply with, so 2, oxygen is 6. So 23 times 2 plus 6. 52 times 0.02, guys. So, am I wrong somewhere? 52 times 23 times 2 plus 16. 62. I'm sorry, 62. Let me try again in calculation. We can do mistakes. Yes, 62 times 0.02. I am getting 1.24 gram. Interesting. Now let's try the next. Oh, yes. I would say do try this question yourself using moles to balance equation. Yes, I just gonna take a pause here. We'll upload the next part of video if I will find your comments in comment section. Thank you so much for watching. I request do share that video with your classmates. Have a nice day. Enjoy.